Alright, hey guys, my name is Newton, and today I'll be teaching you how to solve textbook page 110, question number 2. Let's get started. So, for question number 2, the question asks, you use a string to suspend a cork ball with a mass of 22 grams from the ceiling of a moving speedboat. The ball and string hangs at an angle of 32.5 degrees from the vertical. Part A. Calculate the magnitude of the speedboat's acceleration. Do you need to know the mass of the ball to make this calculation? Why or why not? Alright, let's get started with this question. So the first thing that we have to do is we have to state our givens. We're given that the mass of the ball is 22 grams. And for this question, since we have to calculate using kilograms, I converted 22 grams to 0.022 kilograms. And this is because there's 1,000 grams for 1 kilogram. Next, we're given that the ball hangs at an angle of 32.5 degrees from the vertical. And you can see that from the diagram as shown here. Next, we have to draw an FBD of the situation. So for the FBD, you can see that there is a force of gravity acting straight down. And then there's a force of tension acting up at an angle of 32.5 degrees from the vertical. Alright, now that we have listed our givens, drew a diagram, as well as an FBD, we can get started on solving question number 2a. So for this question, we need to solve for the acceleration in the horizontal direction. And we know that F net equals ma. So if we take a look at our free body diagram that we drew earlier, we can see that the only force acting in the horizontal direction is the horizontal component of the tension force, and that can be found with Ft sine theta. So for F net, we sub in Ft sine theta equals max, and that gives us equation number 1. And before we move on, let's let forward and down be positive. Alright, so taking a look at Ft sine theta equals ma, we notice that we don't have Ft sine theta, and we don't have the acceleration in the x direction. So what we need to do is, as our first step, we need to take a look at the vertical components of the force and solve for Ft. So taking a look at the vertical components, we know that the F net in the vertical direction is 0 because the ball isn't moving anywhere in the vertical direction. And we notice from the FBD that the forces acting on the ball in the vertical direction are Ft cos theta and Fg. So we sub that into the equation. And we isolate for Ft to get the equation number 2, Ft equals mg divided by cos theta. For the next step, we can now sub in Ft in equation 1 with equation number 2 and solve using the horizontal components. So taking a look at our original equation, Ft sine theta equals ma, we can sub in Ft equals mg divided by cos theta. And we notice here that the mass on the left cancels out the mass on the right, so that eliminates our mass variable. Now we're left with g sine theta divided by cos theta equals ax. If we factor out g, leaving sine theta divided by cos theta, we learned from trigonometry that sine theta divided by cos theta is equal to tan theta. So we sub tan theta in, and that gives us the equation g tan theta equals ax. Now with the simple equation, we can sub in the values of g and theta to solve for ax. And that gives us a horizontal acceleration of 6.24 meters per second squared forward. And the second part of the question was, do we need to know the mass of the ball to make this calculation? The answer is no, because as seen from the steps here, the mass variable on both sides cancel out each other, and therefore we don't need the mass of the ball to make this calculation. Alright, let's move on to question number 2b. Determine the magnitude of the tension in the string. Do you need to know the mass of the ball to make this calculation? Why or why not? Alright, to solve for Ft, we can use vertical components. Now recall from part A that the forces acting in the vertical direction is equal to 0, which gives us the equation F net y equals to 0. And the forces acting in the vertical direction, as shown in our FBD, are the Ft cos theta and Fg. So we plug that into the equation and isolate for Ft, giving us Ft equals mg divided by cos theta. Now we just sub in the mass of 0.022 kilograms as well as the gravitational acceleration of 9.81 meters per second squared, and of course the angle of 32.5 degrees. And plug that into your calculator and you get the magnitude of tension of 0.26 newtons. So the second part of this question asks, do you need to know the mass of the ball to make this calculation? And for this question, we do, because we know that Ft cos theta is equal to the force of gravity acting on the ball. And the force of gravity is impacted by the mass. And therefore, we do need the mass of the ball to make this calculation. Thank you for your time, and I hope that you now understand how to solve textbook page 110, question number 2.